IEA, Dr. Vijay Karthik sir, to introduce our esteemed chief guest.
Most respected Dean, esteemed chief guest of this inaugural function, respected head of the Department of Instrumentation Engineering, faculty members and students of our department. So very good afternoon to all. I deemed it pleasure and privilege to introduce tireless and dynamic person who is none other than Premada ma'am, retired Group General Manager, Engineers India Limited, New Delhi. So ma'am has received her BTech degree in Instrumentation Technology from MIT campus, Anna University. Further, she obtained her master degree from IIT Delhi. Ma'am has joined as a management trainee engineer at Engineers India Limited in the year of 1983, and she has risen to Group General Manager of Engineers India Limited. She got over 36 years of work experience in hydrocarbon sector, and she served as a vice president at Tune Energy Service. Currently, she is working as an independent consultant, providing engineering service to various organizations. So ma'am has contributed to the hydrocarbon sector in the field of instrumentation, automation, telecommunication, SCADA, and information technology. So during her career spanning over 3 decades, she has been associated with many assignments covering wide spectrum of hydrocarbon industry, ranging from offshore pipeline, gas processing, refinery, petrochemical plant installed across the country and also abroad. Ma'am has the distinction of having associated with all major clients of India, such as IOCL, BPCL, HPCL, ONGC, and SR Private Limited. And moreover, she had a hands-on experience on not only design and engineering, but also site execution, commissioning, and handover it. She has been involved in bringing in digital transformation to industry, which include implementation of wireless technology-based system, enterprises level management information system, remote monitoring of plant asset, and implementation of workflow-based software programs for project implementation. She presented many technical papers in national and global technical conference. Moreover, she organized many conference technical programs to bring in synergy between end user, engineering professionals, education institution for adapting latest technology in process industries through various organizations like ISA and Indian Institute of Chemical Engineers. She was honored with the Excellence in Leadership Award by International Society for Automation, and she received a prestigious Petrotech Award in Women Executive category. So on behalf of Instrumentation Engineering Department and IEA Organizing Committee, I should thank to ma'am for accepting our invitation immediately. Thank you, ma'am. Ma'am, we are very honored by your presence on this occasion. Thank you for being with us.
Thank you, sir. We are truly inspired by your works and accomplishments, ma'am. I'm honored to invite our respected chief guest, retired Group General Manager of EIL and the recipient of Women Executive Award by Petrotech, Ms. Premada, to present the inaugural address.
Yeah. Oh. Okay. Respected Dean Dr. Tyagarajan sir, respected HOD of Instrumentation Dr. Papa ma'am, Professor Vijay Karthik, and all the office bearers of Instrument Engineering Association. I know the names, but I just telling all the office bearers and all and my fellow students. I'm still a student. Being a part of instrumentation and MIT is a pleasure always, and I'm really honored by your gesture of inviting me for this inaugural function. This is really an honor for me, and it's a homecoming. Every time I come to MIT, it's a homecoming for me. Only this time it's virtual, but still it's homecoming for me. It's really a pleasure to know. Actually, I'm very happy and proud to know that instrumentation department has achieved so many milestones in MIT, and having a great collaboration with the industry and other institutions. And really great. Our students are in Stanford and many places. It's really hats off to our faculties and the instrumentation people. And I wish that many more things will, many more people will achieve much more heights than this when in future time. Actually, for automation and control, I don't know how to start it. I just asked Papa ma'am what to do, what to address, because you all, I feel, as a student, as a faculty, and as an institution, you know much better than me. I just a tip of a little bit what you know, because I'm still learning. But then in this, then she said just to share your experience. During the pandemic time, you might have heard a lot of TED talks, which are all delivered on a precise timing, in a precise format, and excellently delivered. But mine will not be a TED talk, but it will be a pep talk. Just I wish to share my experience. If it is of any help to people like students, it would be it's a great honor for me. Joining MIT was a turning point in my life. It is not only me, many people will be saying this, and especially to this instrumentation department. If any of you, oh, I'm sorry, presentation is.
Yeah, Priyambada ma'am.
Yeah.
Yeah, I'm Professor Tyagarajan. No, ஒரு தடவை சொல்லுங்க, first year பசங்க எல்லாம் கேக்குறாங்க அந்த வார்த்தையை.
Yes, joining MIT was a turning point in my life. I will say it 100 times. And joining in instrumentation was the biggest thing happened in my life. I am saying this after 36 years with conviction in life. So what you have done is a great thing in your life. You will realize this.
Thank you.
Once you go to the industry.
Sir,
it's enough. It's enough.
Thank you. Just to motivate these guys.
Yeah, that presentation, where do the slides are gone?
It's
it is
visible.
there, ma'am. We could see your presentation, automation and
One
control.
second,
Yeah.
one second. Open share tray. Open share tray. Okay. So I just want to show, share a experience of mine in a very small steps. Automation and control is the field of future. Okay. And why engineering? Sometimes we join engineering because most of us, for 90% of us, some with passion, some with because it says engineering degree guarantees a stable and well-paying job, office job. It's nothing wrong in that. Then only 7% of the engineers actually graduate, takes up the engineering job. But is it bad? No, nothing. When we say engineering hardcore, it's an engineering job, but any other job
Sorry
is
to disturb. Ma'am, the screen is not shared. Actually, previously we could see the screen.
Okay.
Now we couldn't see. I think you stopped sharing instead of starting.
No, Sabita, we could see her screen. Sabita,
Oh,
we could see her. Yeah, we could see.
But
her.
I'm not able to. Yeah, 1 second. Sorry.
Yeah.
I have to now.
Yeah, ma'am, we could see your screen.
Actually, I am not able to see my screen. 1 second.
Yeah, why engineering? That screen we are able to see.
Okay, ma'am. Then my system is slow. Okay, ma'am.
Yeah, it's okay. It's okay. Yeah. So this is. I'll put it in a sharing mode. Then see, there are 1.5 million engineers enter a job market every year. You are 1 in million. Maybe when you look at this way, 1 in million looks very, very tiny. But if you see the population of India and the requirement of India, 1.5 million is not a big number. And you have a degree and a skill, so you can enter and do many things in the industry. And I am telling you from all my experience, that is the right time and the right place. You are right college, you are there. And this job market is very vast. The nation is just coming out of this pandemic, and not only nation, the world needs you. But only thing is, you have to rise and have skills to be a part of this challenge. Now, whenever we say, I know I may be just doing some basics, but whenever somebody asks you as an instrument engineer, we are measurement, control, and automation engineer now. So whenever, because anybody says any automation, and we are the drivers to this one. And we are the instrument engineers are the driver of technology in any field, from any manufacturing that has to go to next level. It is the automation and control which does it. And we are the bridge between information technology and operation excellence. When I say this, like information technology develops a lot of algorithms, things, AI, everything it develops. Maybe catering, it normally starts with financial or finance sector, or like Amazon, like tech, or in the Google, how to recognize face recognition. So many things they do. But to bring it to the process industry or any manufacturing, it is the instrumentation which does this part. And we are always been, whenever an instrumentation engineer is there, we are the key enabler for enhancement of productivity, efficiency, safety, and sustainability of any processes, plants, machineries, and systems. Just read it. It may look very obvious, or it kind of, it goes above your head. But automation, whenever you put up a plant or anything, the next delta, that is next delta of getting into productivity or efficiency or getting more money for the same process, the only department or only stream which does it, the instrumentation or automation or the control. So that we are always been called as a key enabler. Even in the case of environment control, anything, and you have seen this, per drop more crop. What is that? What is that? How have even we pervaded into the into this agriculture? What how agriculture is enabling you now, this drip irrigations and other things. If you just go to the drip irrigation, it's the last drop is controlled and sent. There is a solenoid valve system is in place. So instrumentation has gone everywhere. So I'll just give the example how it is happening. So getting smart means getting more instrumentation. Old cars you have seen. We have seen our grandfather's cars are sometimes in the rallies also. We have they maximum have 4 or 5 sensors, and all hardwired, and it does the basic function. But when you move to the higher end, when over the years, if there is an improvement happens, that happens because of automation and sensor. Of course, the mechanical aspects are very important. Like for example, engines more efficient, mechanical engines, and the designs, material, everything is important. But the real edge comes from one generation to another, is coming from instrumentation. So now a minimum sedan car or a car now has 100 sensors. Have you seen the recent cars which have been given Mahindra? Anybody can say that Mahindra, any new cars have come? Okay, I don't drive, but I see this very curiously. What are all the new releases? There is a XUV 700 car which is coming, which they say the key point for them is the ADAS. It is a automated cruise control, and it says my dashboard is intelligent. What that makes that intelligence to the car? If whatever improvements in the mechanical system or things are there, the intelligence come from instrumentation. So every car, this is a Volkswagen old car slide I have taken. This has something, it says that I think 100 plus sensors, where are all the sensors are put. And it says more reliable, more fuel efficient, environmentally friendlier, safer. All this are attributed to the instrumentation and control. So whenever there is a next generation move is there in any field, it is because of instrumentation. So coming to the industry where I work, I joined in the process industry. I was fortunate to, from MIT, gave me all kind of training to enter into Engineers India, which is a leading consulting organization. And it's a hydrocarbon industry. where it's a process industry. What is process industry? I don't need to tell you, you all know. Either you have all ingredients to make a product in a predetermined way, or you have a raw material from where you derive products. So hydrocarbon, oil and gas is the backbone for energy throughout the world. 42% of India's energy coming from hydrocarbon. Whatever they may discuss in the Glasgow Convention, it says 2070 is the switch over to green sustained energy fuel. The hydrocarbon is going to be there. So the process industry, hydrocarbon, when we say it is from the oil exploration, this is called the upstream. Then we have the distribution, because it has to be distributed in pipeline, or the refineries and petrochemicals, or the distribution of products. So these are all encompassing a process industry. When I talk about process industry, it is also true with every industry that is associated with process, whether it is food and beverage, or it is power industry, or this could be a pharma, or it could be a glass industry. So these are all included in this. So my experience just says about process industry, it can be extended to anything. So this slide I'm presenting, because you all maybe, half of you may be knowing, barring the first year, this is how brick by brick the process are made. This is one industry where whatever we learn in the college, every aspect of it is applied. So our instrumentation A to Z is covered in this, but the basic building block is the same. You never forget that any instrument, when you are an automation engineer or an instrument engineer, the basic building block is only only the three aspects. One is your sensor or transmitter. Then you go to the control system you apply, and then other thing is the final control element, how you give the feedback and control the process. So, and this also includes the safety instrumented system, which is similar. On the top of it, every process plant has a safety valve, which is a mechanical. So whatever may be your car, there is always a handbrake. Why? Because that is how it is. That is the last line of defense. So this entire thing today, whether they call it IIoT or enabled, or it is a normal process industry or any manufacturing, this is what is the basic idea. From here, we build the plant. So these are all the four elements as an instrument engineer. This is the fundamental transducer, and then we have transmitter, which transmit the signal to this. And then the transmission media, because it could be cables or wireless, or the medium of protocols and other things. And we have a DCS, this controllers, or the advanced controllers, or call it computers, whatever it is, or it could be a manual control. And we have the final control element, which is control valve or other motors. And control valve is like a soldier, whatever maybe there's a defense system, Air Force, everything is there. In the front line of the border of China, it is our soldier who, with his bare hands, fights with the other soldier who is facing the thing. So this is the final control element is very, very important. It may look like a small pawn or anything, but without final control element, the whole process cannot function. So this will be repeated in all our thing. So when I was in MIT, sir mentioned about the industry visit. I used to we were taken to a Madras fertilizer plant or something. Then they showed us every place. That time it was a very vast. I was like just aghast. Oh, so big. And then I was thinking how it happens, how they are showing something is controlled by this and all those things. I said, how they will be building it. So I thought, let me just give you the building block, or the brick by brick, how it is built. So once it is broken and shown how it is built, then instrumentation becomes very, very simple. So what we are doing, there is a measurement. I told you, there's transmitters. We take the signals from the field. So instrumentation, is the window of the process. Okay. So how do we how it views the process, how you feels the process by transducer or transmitters. So they all connected to a junction box. And it is coming to the control room with main cable. The only thing is, in a process industry, probably I can quote for one plant, one refinery, because I have done many refineries from the greenfield, they call it, from the beginning to final. Maybe something like 25,000 such wires and cables coming. So many signals will be coming. So everything, or something like 10,000, 20,000, sorry, 10,000 loops will be there. So everything is built brick by brick. Then they go to the control room through the main cabin. So now from the field to the signal, how it is taken, you know the basics, 4 to 20 milliampere. 20 milliampere is the transmitter it comes. It still rules the process industry. Almost 50% or 60% of them are in 4 to 20 milliampere. But one beautiful thing happens is, from the transmitter, we also get a digital output, because every transmitter is a computer in itself. It can tell what is happening inside its own arena, whether the sensor is okay, or what is happening. So all this information are transmitted over a field communication. It's called a HART protocol. You must be reading, but this comes to the control room. But the same 2-wire carries this. Okay. And then there are direct digital communication is there. From transmitter, things go digitally directly to the control room. So this is one of the most prominent one. There are other things are also there. Foundation field bus. It's a two-way communication. It talks directly, digital talks from field to the control room. So this is replacing the traditional point-to-point wiring between a field device and controllers. So simple, all the cables come to the marshalling, and marshalling is, this is like an entry, hundreds of cables coming from the field. You cannot just connect a signal to a computer. So you need a kind of arrangements and also things. That is the marshalling cabinet it comes. And then internally, they talk to the systems, which are digitally talking, because from marshalling, it goes to the system cabinets, where analog is converted into digital. Digital is converted into meaningful information to the systems. So this is the second building block. It comes to the control room. Now, so this gives the overall signal connectivity to how from field to DCS, how things evolve in a macro level, big level. I'm giving a big picture. You must be seeing it in your lab. I'm very happy that you have all these systems in place. Please go and see how each connectivity is done. So this connectivity is done from field to how it's going to marshalling, or how it is maybe in your lab, the marshalling and controller could be in the same cabinet, but you can see this one. So in the industry, this is an enlarged, in a very big way it is done. Then you will see all kind of communication protocols used here. 4 to 20 milliampere with digital HART, or direct digital, or sometimes only 4 to 20 milliampere, and also some data communication cables. And then there are internally communication cables, which is internal protocol to the system. So it is a work of complete manufacturing, and also some wiring, marshalling, and the engineering, and also the communication, everything in place. Then each refinery has hundreds of machines. Machine, I feel, I mean, is the motors or the compressors. I give you an example of one refinery where we will be having something like 2 to 3,000 motors will be there, small, big, like that. And there will be big compressors. They look like a plant themselves. They are big power compressors. There will be 20, 30 big machineries will be there. So each machine has its own control system, because they have to internally also monitor themselves, and also with the process. So this machinery controls or the electrical controls all done by instrumentation. And generally the dedicated PLC, programmable logic controllers, which you all know it. They are dedicated, and they are also connected through Ethernet or direct Ethernet or other communication to the DCS. So that DCS is a central point to receive all the machinery control, but each machinery is independently also controlled. So this, when I say I'm doing an engineering of a plant, it's sometimes, you know, in normally a refinery takes almost 3 years, 36 months or 40 months to build. It's a big, massive work. Most of them looks very routine also. And we encounter a lot of cables, and then we encounter this kind of, I've just shown this some photo, how it all looks when in our control room, in the rack room. So many things will be assembled, and we have to check and do it. So this gives you a picture of how in macro level things are done. And this is the motor control. It looks, you see, earlier the motor controls used to be on relays and small PLCs. Now the DCS systems and big PLC systems have replaced the motor control. This motor control, they also become very complicated, and instrument engineers are more and more involved in electrical systems. That's why I just want to show you this one. So finally, we are coming to the operator control room. This is where, from the field, brick by brick we build, and then it comes to the control room, and this is where all the action happens. This is the nerve center of a plant. It could be, I could call it as a brain of the whole thing. Without control room, you can never think of any process control, any refinery or refinery can be done anything. It's shut down. If there is a problem of brownout, we call it, power dip for more than some time, there is a backup. If that fails, entire plant comes to a stand still. So control system is a nerve center and brain of the process control. You know, whenever we finish that refinery petrochemical plant, then the CM or the Prime Minister comes for inauguration. Before taking him to the field or anything, first thing we show is the control room. This is the show piece. You have seen in ISRO also, where when there is a launch, where the people are sitting in the control room. So that is the window to the process. The instrument engineer is responsible for each and everything that goes in this, from every graphic, every connection, every function like controller, every functionality, tuning. Instrument engineer is responsible for this, and we have to design. An instrument engineer is responsible to design a plant where the control system has to run for 24/7 and 365 days. There is no room for any failure. So that is the kind of precision we have to take. That is why it's a big challenge and very nice experience to have to do it. Even if it is a small motor control, you really feel if you do a small motor control. If you add, for example, if you have a tank in your house where your overflow, when there is a when the water comes, there is an overflow. Then what do you see when you see the water coming out through the pipe? Then you go and stop the motor. Just see and add some sensor, level sensor, high and low. High will trigger the low will trigger the motor. High end will switch off. How good you feel to add automation, because you will be saving the panic. You will be saving the water. you are happy. Anytime when the water goes, it will go. It switches on, and water goes high, it switches off. So how how it makes your life very simple. So this is the kind of happiness, or sorry, it's the kind of achievement we bring it to the end, to any process plant. I can also tell you, this is an action point, and everything happens. First, the instrument engineer is called. See, in a process, when the temperature goes very high, for some reasons, the medium is heated very hot and temperature goes high. They will not. They will just call the instrument engineer and say whether this instrument is okay, because you don't. You always want to know whether your instrument is right, whether you have really a fever or there is a problem with your thermometer. So this is the kind of responsibility. The instrument engineer is always on the toes to run the plant. And in order to run a plant in a very smooth way, it is also the design engineers or the people who build the plant to give a system which ensures this kind of thing. Instrument, there is a big saying by an industrialist, I forgot his name. He says, very well run plant should be the most boring place in the earth. Why? There is no action, there is no panic. So there everything goes smoothly. Then if your hands-free road is good, your vehicle is good, your hands-free, that is the most happy moment. But it's also a boring moment for the engineer to or the plant. So that making the whole process control and also the production a boring process, routine process, is instrument engineer's job. So that is our achievement. If the plant is run without any problem, it is the instrument engineer who has done it. Instrument as a thing done it. Of course, other things are also very important. Having said that, I just this is the thing I have just. Having said that, the instrument engineer is also responsible for many other things. Here, what I have done is I have just put the functions of an instrument engineer for process plants, because having experience in the field, you can read it slowly. One is the engineering of field instruments. Okay, this is a building block brick. It's our job. Even to do the tuning, you have to make the correct controller controller to select whether PID, whether PD or PID or feed forward. All these are our part of our system. That is understood. And also safety. Plant safety is very important. Why plant safety in process is very important? What are we handling? We are handling the hydrocarbon. We are handling crude. We are going petrol. We are handling diesel. We are handling LPG. So in a process plant of refinery, so it's hazard everywhere. So there is no room for any failure. No Bhopal. Nobody wants any Bhopal incident any longer in any part of the world. So there is a defense of safety system defense should be in place. That is done by the interlock and shutdown systems. That is part of instrument engineers scope. And also power and motor center, which I already told. And also machine monitoring. There are big machines. Of course, if there is a problem, mechanical engineers, everybody come. Before that, the instrument is the one which says, yes, this shaft is not, there is some problem going to happen to the shaft because it has overworked. There is a problem. So that is always predictively told by the instrument. So it is maintenance sequences or scheduled by the instrument department, or instrument does that one. And then integrated asset management. I just want you to listen to some words, key words, which are told in the industry, any industry for that matter. An industry normally now calls asset. What is asset? Earlier, we used to call it as a equipment. We used to say motor or pump or a vessel like that. Now they are called asset. So every asset is very important, because without not one motor of that I told you, 1,000 motors, if one fails, you cannot run the plant. It will be a disaster. So the asset management and all the instruments will give you what is happening in the asset, apart from process, apart from making the process work for it. So this integrated asset management system is also instrument engineer. And of course, control room and engineering. Control room engineering is what I would call, even the control system, how it is arranged and all. It's an engineering, but it's also an art, and it's also a kind of science. Both. It's more of art. Why? If somebody is sitting, you imagine a control engineer who is running the plant is sitting for 10 hours, staring at the plant through this system. There should be an ergonomics. There should not be any kind of problem for him. And how you put that plant in place in the display, these are all very important. Even lighting is very important. These aspects are taken care by the instrument engineer. That is where we always go with the architects, how the things are arranged and how differently things are put. Then since we are in safety, as an instrument engineer, we are in safety. Naturally, we are put on fire and gas system entire. This is the external fires and also the external things which disasters which may happen. Whatever you do, this may happen. Some leak will be there. Some gas cloud may be forming. These are all the complete thing is part of instrument engineer. And of course, advanced control on modernization. You all know, maybe third year, fourth year, you may be knowing the advanced control. Because once we are putting a plant in place, we never want to. We always want that delta, little bit more in earning more. So that little bit more is tweaked or done by the adjusting the controller and its functionality, or making a small changes. For example, a plant is done for 100% capacity. After some time, you may feel like making it to 110%. It is possible, because there will be a possibility. So what you do through the control system, you can do it, and do the advanced control, you do it. And the modernization word is very important for an automation engineer, because in any process plant, they are actually done for 25 years. A vessel is designed for 25 years. Okay, a compressor is designed for 20 years, or a big heater. Mechanical equipments are designed for 20 plus years, because everybody having invested so much, the plants have to run for 20 years. Some of the plants are running for 40 years also. But whatever you may do, you may put an instrumentation or automation, everything changes in 5 years. You know it. Any of your mobile phone, can you really keep it for 10 years? Okay, when the normal non-smart phones were there, we were keeping it for many years. But every 2 years, 3 years, you keep changing. And I don't know, when you go for a job or something, you will be doing it much more than that also. That is because you have new features have come, and your requirements have also enhanced. And there is available things, and there are obsolescence which comes. There are some softwares, you cannot use it in old PCs. i4, i3, you cannot use it. So you have to migrate. Like you are migrating to the computer. If it is not that extent, there is always a migration in instrumentation, that we call it as a modernization. It also, every time we modernize a plant, it's always giving you the value addition. And engineer is also put in CCTV, closed circuit TV, you know, no? This is under security. All those things are part of instrument engineers domain, and safety studies are part of it. And what is blending automation? I call it as a science. Because have you ever gone to a petrol pump? You all must be going it. You call for a 93 octane petrol. Okay, how you arrive at? It is uniform for every lot of petrol which is coming. So where various petrol produced in the units are blended to give a specific, which meeting the specifications. It's a very big science in itself, and implementation is a very advanced technology. And oil and gas terminal automation system, where hundreds of products are coming. We are talking of million metric tons of products. Okay, so every day hundreds of vehicles will come and load and go. These are all maze-like type of thing. Everything is automated, and that automation is a part of instrument engineers domain. And for very good reasons, I would say, or very strange reasons, the telecom and SCADA systems are also for part of instrument engineers domain. Generally in process industry, the instrument engineer is trained to handle the telecom systems. That's because they are a very small part of it, but they are very important also. And secondly, instrument engineer is always versatile. So he can take up anything, whether it is telecom or anything. So he's always been with confidently given. This telecom and SCADA for remote installation, because you have a sometimes refinery in Bhatinda, which is in Punjab, which does not have any terminal or port. The oil comes from Kandla, which is in Gujarat. It may be 1,500 kilometers away. Every day it is continuously getting crude oil. So how? It's through the cross-country pipeline. I showed you, midstream, which is the distribution. So this telecom, SCADA, and control of pumps in between, all are part of instrumentation responsibility. So same with the automation of pipeline, and not, I would say more things are there, but not but the least you normally say, no? IoT solutions very rightfully in all process industries now are interested on instrumentation people, instrument domain. That is because I told you, we are the bridge between the new technology in whether it is IT or it is any other domain, and which we are bringing into the process. The instrument engineer is by nature, by training or by the work, they are seen as capable of doing it. That is the real reason for IoT naturally coming to us. Then but having said that, don't think it's instrument engineer alone can do the whole process, refinery building the refinery. It's not so. Building any process or any small thing, even if it's a manufacturing or any small unit or anything, it is coordinated and also very widely by various people and various divisions. No, engineering by nature is not a single person's achievement. I'm saying this, even if you you have a startup, it is not one person can think of the idea, okay, but the idea to materialize, to do that, you always coordinate, you need people. So please bear in mind that any engineering, if you call yourself engineering, you are always bound to be a team player. Your individual excellence is really required. Individual department or division's contribution is required, but you are a part of the big team, big picture. So, but the very beauty of hence, instrument engineer is always been in touch with others also. Process division, they do the process, the chemical equations and do the basic process calculations and all. They are the chemical engineers. Then we have civil. I told you, even civil architecture, everywhere we have to go. Mechanical, where pipelines are going here and there in that, you have to also maneuver. Electrical and telecom, we are the telecom, or if there is a separate telecom, it's also information technology. Yes, because there could be a lot of technologies, program things we may have to develop, which is to tune to this process industry. That's also coordinate, and then construction, operation, and safety. So we are when you are an engineer, you are a team player, And this is true in process industry to the large extent. I can tell you how many people will be working in industry. There is one refinery when we went for commissioning, it was construction was going on. It's in 3,000 acres of land, and there are at time 35,000 people were working. Various disciplines or various things. It could be the laborers, it could be engineers from manufacturing, it could be the equipment manufacturer coming, and it's like a big mela. If you have gone to Kumbh Mela, I don't know, maybe in a lifetime you must go. It's things happening. So these all are the coordinated effort, and you are a part of the thing, but you are a very important part of the entire thing. That is the pride of the instrument engineer, who are to coordinate. So it's this slide. You can just see it. You may not be able to understand what I'm putting. It's just for our trainees. We normally give this slide when I was working in both the companies. An instrument engineer by nature has to work with all the department divisions, like civil, piping, process, electrical, static. It looks like an octopus. He has to maneuver through the various things to get into the system, because we are the window to all the systems, and we are the responsible for the functioning of the final what is seen in the plant. So it is very important that automation engineer or instrument engineer has to be coordinating with all. This really gives us the resilient. Any engineer who join in any industry, not only here, even in other manufacturing, any industry, they become naturally resilient and also multitasking and also multi-knowledgeable, because we are bound to coordinate with all the people. That's the beauty of this instrumentation engineer, that makes us more versatile. And we have to see that I am a part, and I am a very unique part, but I am also part of everything. So that is the thing. Now I just want to give you one small thing about job divisions in process industry, because most of you think that everybody joins as an instrument engineer has only required to go into as an instrument engineer and do the control system and all those things. It's not like that, because instrument engineers are put in everywhere. Like, for example, I joined as an instrument engineer. For many years I did as an instrument engineer. I have seen the transformation of technology, all those things. For maybe 22 years I was in hardcore instrument engineer. Then I was also taken electrical engineering as a responsibility, and then finally IT engineer. I was heading the IT division also. So how is it possible? This is how the process industry, you have various divisions where you can be put in. It's not just an instrument engineer, but your training will give you, by nature, we are adaptable to any position, anywhere, any divisions. Some of them are engineering, consultancy, project management is a big thing. It could be a marketing, sales, operations, maintenance, of course, and manufacturing. Yes, you can be a manufacturing thing. IT sector, software development within that organization. Of course, research and development, procurement and logistics, testing, inspection, execution, safety, of course, it's a part of it, and documentation and data management and analysis. This is a very important part of any process industry, because history will tell you what is going to happen tomorrow to any equipment or anything. So this is entrusted on instrument engineer. And the beauty of instrument engineer comes here, which nobody, no other, of course, IT is a thing I can tell. Instrumentation is in forefront of adopting the latest technology. By nature, instrumentation is like that. In IT, whether it is IT, telecom, science, of course, science, electronics, materials, and more. How IT? when the IT evolved the many programs on this, instrumentation adopted it and came out. Science, of course, science is the basis for instrumentation. All your sensors have come from one lab or one university or one program. It may be a space program in NASA, like oxygen analyzer. Analyzer is a product which was used in NASA for space program. That is industry adopted instrument in industry adopted that to it. And the spectroscopy we adopted in instrumentation. And then telecom, of course, it is. I have shown you all these things. So, but what it makes instrument engineer different from others is always since you get used to the change, you are also learning all the time. So that puts the challenge. There are a lot of, you are forced to face this challenge to keep pace with technology advancement in terms of knowledge upgradation. An instrument engineer, I graduated, I cannot sit as 83 technology. I had to progress. And secondly, and then not only that, you have to translate. Instrument engineer has to translate to their industry how things happening around. Like for example, in IT, that program or anything, which how we can adopt to our industry. That is the challenge of instrument engineer. And this technology updation is all from pervasive. From controls, from field sensor to control system, everywhere it comes. So wherever domain you, subdomain you are working, the changes are going to happen and you have to be updated with that. See, I give my example of this thing. When I joined, there were pneumatic instruments were there in that. You never know that pneumatic instruments. Very good that you don't know. We also learned, we had a course also, course and things. Then when I joined, it was transferring to electronic transmitters and instruments. And just when I joined, the smart transmitters are introduced. Electronic transmitter itself became smart. You tell me in the public domain, the word smart or smart things came when? Probably 2003 when the smartphones came. But you know, in 1983 when I joined, they said we had a smart transmitters. What was smart? That's why smart. What was smart? It was a dumb electronic instrument which was just giving the signal, became smart and giving more and more information about the healthiness of the its own transducer things and its circuits and what was the problem inside. So, and it also tells us when you had to calibrate. These are the, it's like it was giving, talking more. It was talking about itself more. So that smart thing came in 78 itself, and when the industry it came, it 82, 83, it became very fun. And by 88, everything had become smart. And also it went into digital, which is multivariable, and various instruments in variables can one transmitter. Now wireless. So I have seen the transition of 4 generations. It's at least 2, I would say, is a paradigm shift. Paradigm shift, it's what? It's a generational shift from pneumatic to electronic, electronic to digital. 2 things I've seen as it. So now things are much more dynamic. When you are entering into an industry, probably in 10 years down the line, 3 times the changes will happen. So an instrument engineer gets an opportunity and also be prepared to face these challenges. It's a beauty of instrument engineer. This just I'm giving the how the control system also went through many things. Of course, I did a lot of jobs that time, from pneumatic to directly digital, transferring the control system from pneumatic to distributed control system. It was a big shift. We have to convince the operators that Bhaiya, you just leave the pneumatic. This is the new things which are coming panel. You have to work on that. We have to take classes. We have to convince them. But now, when the digital came, distributed digital system came, slowly there are so many things are happening. You see, every 5 years there are things happening, and also standards are also evolved. Within the span of 10 years or 12 years, things are happening. Now I think there is two more. I could not put it. I did not put it. I could not put it. But things are happening, which means that anything happens in technology front anywhere, instrumentation is ready to absorb that. So that puts us in ahead of any other department, any other divisions. And then Papa ma'am asked me to talk about little IIoT. Probably I'll do it if time permits. Now I come back to the thing which you are all, which I want to share with you. There is one aspect of instrument engineer I want to share. Probably in a process industry or any industry, sometimes you may feel you are not, we are not a very significant contributors or part, like a mechanical engineer or a civil engineer or a IT engineer, because or a computer systems and all. That could be the normally an instrument engineer feels so. But one thing you must remember, this automation which brings in is a small part of any process industry or any system. We used to joke as an instrument engineer. We may be a very the control room instrumentation in a very big refinery. Automation or instrumentation cost is only 8 to 10%, maybe 12%, or like that. Whereas 30-40% is the equipment and big machinery cost and other things. With all the DCS and everything, our part, the contribution is very small, it comes. You may feel, then I always tell them, yeah, volume wise, we are right. Even the brain is compared to the weight of 65 kilos of body weight. What is the weight of brain in grams? But can you live without that? So that is the importance of this. So many industries have started realizing that, and there are more opportunities in many industries. That's what I see from the day we passed out, and now more and more instrument engineers I have seen in domains which we would not have even thought of that time. You know, that is there. Some I have listed based on my experience, because I have just I have not put anything which I don't know. There could be many more industries where people are there. Maybe software information technology, they take it. There are instrument engineers specifically called in, even if you have a little bit experience in instrumentation, small companies, maintenance or this, software they take, because some of the trainings are required, some of the applications required instrument engineers background. And robotics and artificial intelligence, I have seen few people they have done, but I am not, frankly, I have not seen mechatronics as many, even though they call it mechanical engineers and electronic engineer, it is actually the automation engineer who is driving this mechatronics or the thing. Then aviation and space, you all know, many people have joined. Telecom, yes. Oil and gas, of course. Process power plant, electrical and electronic industry, they are all placed. Fertilizer industry, many, and fertilizer industry is also opening up now with that. Cement and paper, or really instrument engineers like any other process industries, them. And food and beverages, yes. Healthcare and pharma, yes. There are a lot of healthcare also, pharma also. You have seen in now big hospitals have an instrument engineer who maintains and does the big thing in pharmaceutical industries, like big instruments, they are doing it. And one thing very interesting is the smart city system. See, instrument engineer never used to play a part in building systems or in water distribution or anything. But now instrument engineers are being called for this one. Why? Because when the city or the building becomes smart, you need an instrument engineer, or you need an instrumentation for this. So I heard people are also being done, and the smart city things and pervasive instrumentation has become as a big industry now. It is developing and it's picking up in India also. probably it may take some years to bring into the main forefront. Nonetheless, it's a very promising. And last one, I want to, even though I put it last, I want you to stress on Armed Forces Engineering Services. This one place, let me tell you also, it is the military, I mean all the three armed forces, is one driver of technology in any country. Any country, the military specifications are very, very, very stringent. There is a American thing says, even in America or India, the military specifications are very rigid, very, very strong. Even their safety systems are more than in process industries. Nuclear is another, I have forgotten, nuclear also. So nuclear and armed forces, they have that special thing. They have a lot of budget. They are the driver of technology. And the armed forces have a lot of opening for instrument engineers. Last week, I was talking to one of our seniors, and of course, he's a junior for me, for our MIT, and he was telling not many people now coming forward for armed forces recruitment. But let me tell you, it's a very, very challenging and enriching thing for engineers to join. That's what he said, and he requested me to convey this to you also, men and women, all of them. And another thing I can add is the process of going into armed forces itself is very good, challenging, and also will leave you with a very confidence, because they check everything of your capabilities. So it's the process itself will give you, whether you join or not, the process itself will give you a big learning. So do consider Armed Forces Engineering Services as one of your goals or things. Especially for South Indians, I am telling. In North, I'm just not as a divide, I'm just giving my observation. A son or daughter joining in army or any capacity, not just engineer, doctor, or even a soldier, is a very pride. But not so much I've seen in South. Maybe maybe we are not aware of the avenues we have, and that's why I put this as a point. Armed forces, you consider it as one of your domains to expand. And now again I say with conviction and with all my understanding of the industry, the demand for automation professional is going higher and higher and higher. So much higher than 3 decades ago. It is only there are some skills or things required. After this pandemic, India is looking up. It's the right time. Probably this is a disruption. Yes, nobody can help it, but it also gave us a lot of learning and things where automation engineer can find himself avenue, maybe much more than that. Because of the nature, I keep telling that we are versatile and we have a cross-functional ability which comes naturally to us. That is a part. So you have to just look for. And then automation engineers just don't think about go beyond manufacturing and process engineering. Having come from process engineering, I'm telling this because the avenues are much more than this. So like in Smart City project, I have seen people are deployed and working on that. So now there are this I just want to share with you as a professional from the industry. What is the expectation from industry? Everyone knows who are going to employ you, know that you are a trainee. Nobody is expecting you to know the big skills or things. What they look for is whether you will be in a position to be a part of and excel in the whatever task is given, and you can excel in that. So the first thing they look for you is your knowledge about basic science of instrumentation and control. When I say basic science, when you call yourself as an instrument engineer, you have to fundamentally know few things, okay? About things which I will come back in the next slide probably. And it is very, very important. You may think that, oh, I know the artificial intelligence. I know this algorithms writing. I know this thing. I know the transmitters and how that things are thing. But if you don't know the basic sensor how principles, it will be very difficult for anybody to appreciate your knowledge in the other domain. They may appreciate, but then basics are very important. You should know where I can apply this capacitance pressure gauge, pressure transmitters, where we had to apply some other transmitter, where I can apply ultrasonic, where I cannot apply ultrasonic flow meter, or what are the basics things which gives to this instrument to work. This is what you know is always expected, and what you don't know is not. You are not testing. Nobody is testing what you don't know. Then I tell you, one minute I can take one interesting fact. In one of the interviews, there was one boy from Orissa came. He was a very brilliant. I would say he's a brilliant boy, and this thing. And our senior, Mr. Mahajan, he's the industry. They call him as the father of process industry instrumentation. He and me, we were interviewing. He did very well, everything. But then he could not answer one question. The two questions, it's a basic same question. Pressure gauge, why it is C board-on. And second is, it's that pressure gauge, the tube is not a rounded this thing, it's a helix, small helix opening. So then my senior who was interviewing him could not, he said, yeah, he told him, you are excellent in other things. This basic, how do you miss it? He said, sir, I don't, and I probably did not attend that class, or I forgot everything. It was first year, he said. He said, yeah, you try. Then he was a little shy in front of us and all. Then my senior told him, can we do one thing? We'll phone a professor, because like a Kon Baneka Karorpati, who is coding, I don't know the Tamil equivalent. Kon Baneka Karorpati was famous in those days. He said, can you call your professor and ask him in front, could you possibly do it? He said, yes, my teachers are always, as always, teachers always help me. And then he said, sir, I don't know whether he will be sitting in the class or he will be there. And then I will try. Then normally we don't allow the phones to bring in the interview room. So he went out and got the phone. And then he called his professor. And he was on the line by chance that day. Then he said, sir, I have been asked all these questions, but if I answer this question, I'll get this job. So he said, which question? He said that this is the board-on tube, how it is, measurement is done and how it is. Then he laughed and he said, that was your first class on industrial instrumentation. Then, of course, it was a very, in a lighter way, he explained. And then he got the job. He's still my colleague in my college. What I'm saying is the importance of basics is very clear to you. From there only, you can build your things. And second is, of course, the leverage of digital technology, because there are more avenues now. You have to know what is happening around, and also probably basic things you can know better. So it is always you stay engaged to stay ahead. Whatever you have, you learn it and stay ahead. And these are all some of the domain knowledge. Actually, Papa Ma'am asked me to think, because you may be doing it over a 4 years course. So if you are in a particular industry you are going, most of them I have listed as common to all industries, and especially for process industry I have listed, because it's very important. You should you are expected to know the basics, not minimum whatever is taught in your class. One is sensor technology. Of course, I have said industrial instrumentation, how important, and control theory and control logic. And I am very sure, I am really telling you, you or your third year or fourth year may be knowing much more and even than what I now remember of, what I have applied of. So things are improving, but you have to comprehensively put yourself about these things, because you have to take the interview or the job things seriously. And these are all the things, and signal power transmission and signal processing, you are all very aware of it. So things are very aware. It's fundamental questions, coolly they will be asked. No kind of pressing you. Then analyzer systems, if you are, I don't know, we were taught a lot of analyzer systems. Now I don't know how it is. But one thing I find, MIT people or our syllabus is systems, what you are studying is way ahead. It's very good in line with our industry requirements and with your things in like DCS and all in your lab. Probably you have an edge of getting into any process industry. Only thing is you have to be thorough in what, when you are doing an experiment, for example, in DCS and PLC, you know the basics, but how it is already done in this 3000 Yokogawa Centum. You should know whatever, how it is translated or thing. That little edge will make you. And also like PLC, it's not just knowing the programmable logic control, but also how the logics are translated into process requirements are translated into logic is into PLC. That kind of transition, little bit. It's not you are expected to do everything, know everything. And then it's my this thing for process industry. The final control element is a very important thing. I told you, it's a Chinese, the soldier who is going to defend the entire process. So nothing much changed in this, because the same what they call linear, equal percentage, linear things are the same. But how you are understanding that is very important. That basic IT knowledge, I am this I have put normally because we ask generally what you know of. Especially any project you are doing, whether any project you are doing, be thorough with that. Any industry visit or a training you are taking in industry, please try to learn it and keep with your basics, and however small it is, you put clearly with your mind. And for anything, everything you learn, please put it as a document in your diary or anything. From today onwards, there will be a technical diary till the 4 years or 3 years or 2 years of your learning. That is very important. You just go through. That's enough. You are ready for face any kind of interview or challenges. Then I know any shortcomings in anything, I'm really happy. I have this kind of people say there is a gap in industry and college or institution, which is there. I'm not putting, but then these gaps, the skills can always be acquired. No, absolutely no problem in not getting that one. It's a very thing. I think our Instrument Engineers Association is already doing this group presentations, discussions, debates, role playing, and reviewing of case studies scenario. And think Papa ma'am and Karthik sir all are helping you to evolve this one. Take every opportunity of it. Sometimes MIT Alumni Association also conducts some of the conferences or something. You please keep attending if you have time or doing thing. Because there are 10 things, then 8 may go above your head. One may little bit understanding, one may stay with you. That one is enough. So you go in that, but nothing will go waste. Any learning, nothing will go waste. So, and the industry institute collaborations, I think MIT is doing a very good job. There are centers, you are coming out with the drones and other things. I want instrument department to come with a sensor technology, sensor things that would drive. And in this part, I also, as an industry, I also feel that not many collaborations in from industry side is being taken with our institutions. Somehow instrumentation is so ultra technical driven the import is given more important. But many industries, I'm also talking, we are also they think that it's very important to collaborate with the local industry to do it. And then MIT is really poised for this one. It's a big field player for you. You have a big field to have this, as Dr. Tyagarajan put it. Then this. I think I've taken a lot of time, but then these are all little things I want to communicate with you, which over the years I felt any engineer should have. I don't advise, but these skills actually make the soft skills make one better than as a better person, and also a better engineer. One is communication skill is very important. I'm not saying that bombastic languages of Shashi Tharoor versus there is one more person who keeps debating. Not that concepts are round and round talking. No, not that. What you know, you should know how to express nicely so that the other person can understand. Because that comes only when you have, is very well. It's nothing to do with language. I also studied in a government school till 11th. I've never studied one English lesson, that's all. And also in college till second year I had Tamil. So it doesn't matter. But it is the understanding of your technical things, how you are imbibed, how you are taken it. So excellence, it always expresses itself. So the basic thing is you know it better, and then you probably have to give a shape by practicing or that group discussions and all. Just don't worry about it. Now also I want you to ask any number of questions, any number of ways you have. That is required. It can be acquired. It's not a thing. And then interpersonal and verbal things are very important these days. So any professional to think. And the other thing is, you know of the book Argumentative Indian. Indians are known for arguments, loud arguments, not listening. We argue without listening. So this is a very big thing. I also learned it in a hard way. We don't realize we are probably we are taught, but we don't do it. We take democracy too seriously, so we think anything can be said. So listening is very important. It's learning. Listening cannot be done. It's not a nature. It's a learned skill. Like communication, it is a learned skill. So consciously, probably you try to learn, learn to listen. Whether now I have given lectures, how many of you are listening, I don't know. It could be boring for you sometime, but probably that is what sometimes few words, few sentences, or few communication can trigger you to any level thing. And also probably sometimes the other person may be expressing in a different way, but maybe putting a point. So learning to listen is very important. This will make you a good professional. And another point I want to tell you is, many of you are, especially to the fourth year or maybe third year, who are got into job place or going, everybody, it's telling you from my heart, many people, everybody may not get their dream jobs of 9.5 lakhs or 14.5 lakhs, and then dream programmer in big analytic experts in some or something like that. It may not happen to everybody. It's not a whole system is not like that. But even if whatever you have to take, or you are forced to take due to any other reasons, or you decided to take, even though it is not your interest, but please do it with utmost happiness or utmost desire. Never brood. Turn to you do that. It could be a routine task. You may feel it is not every day, it is not giving me a challenge or anything, but turn the routine task into your skills, transferable skills. This is fundamental required. A person who may get a dream job may not end up in the dream career later, but a person who started with a small routine task may end up in a big career professional or a big entrepreneur, big thing in life. So these are all how your learning is converted into your skills. I can tell you an example of one of the person in Yale who joined, and sorry, no, not Yale, in one of the organization in manufacturing organizations, he joined in Bell's control pressure gauge division. It is a very people say it is a very routine selling of pressure gauge or something. Then he was selling. Then he went into, he said, I want to learn some manufacturing and all. Then he went, and then there was some opportunity there came for some electronic panel. This thing. He was put, because he was marketing, he was put, and he learned. From there, he went to one of the DCS vendor supplier thing. Now he's heading the international Asia Pacific or beyond that. So see the transition. It's like within 25 years, the entire thing changed. Some of us who joined as instrument engineer remained instrument engineers, but this anybody can turn anything if you are if you take your skills with you, learning with you. That is very, very important in my opinion. And this IEA, your whatever programs you are doing, that could be a stepping stone for you. And then last but least, being engineer in chosen field is only a beginning. Let me tell you, nowadays everything is, earlier it used to be electrical, mechanical, physics, chemistry, all those were partitioned, but now everything is merging, because this is how the world is evolving, and it is like it's like a rolling gather. We are all the big mass, so there are a lot of opportunities. People who are who started as an engineer, you may end up in a bioinformatic system analyst, or you may be in you may be a big clinical analyst or something, or you may be in space scientist. You could be anything, but your skill in as an instrument engineer or as this thing, that will take you. This is only a stepping stone. You can always get into anything. And one small example I can tell you, my daughter, this reverse is also true. You may go, my daughter, who told me in +2 that I will not do engineering. This is a statement, and went into her passion of English language, BA English literature, then went to she just attended one linguistic class. She interested, MA linguistic. In that, one professor, one thing, because linguistic is all about how the sound comes, phonetics and phonic things are coming. Then one science, there was a Fourier transform and other things. So one teacher made her interested in electronics and digital communication. And now she has got a degree in MS in engineering from US University. The department is robotics and artificial intelligence. Where is where? People can go anywhere to anywhere. And instrument engineer is better equipped than anybody else. That is my point. So don't have a fixed idea that my skills are not used in my first job, or my skills are not used in my learnings are not used, but all your learnings are always used, will be useful anytime, wherever you go. And I really wish you all the success, and have a great time with your Instrument Engineering Association and the activities. Be a part, and then enjoy your studies. Have a great life, because what instrumentation teaches us in a nutshell is changes for progress. Every day we are changing. Instrumentation, we are taught to be versatile, change. We are facing change day in and day out, and progress is way of life. And I wish you all the success in your life. And my wishes to you all. God bless you. And also my I thank my teachers of our faculty, professors to giving me an opportunity, and I also take this opportunity to give my salutations to my teachers who taught me, and also to the founder of this great organization. Thank you so much, and I take the questions. Thank you so much.